Hello, physicists, and welcome. In this session, we'll be looking at the series and parallel practice packet. This is problem number 6, not 5, but 6. 6 has some additional interesting items that will probably help with clarifying how to do these problems. Let's get started. Hey, as before, I've numbered my positions starting at the negative end of the battery at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then back to 0. What I've done in this parallel circuit, because we do have branches, I've labeled the longest path all the way around the outside. Hey, something else that you haven't seen are these little rectangles. Okay, those are not resistors, but they're just little inline current monitors. So I'll be writing what the current passing through that point is in this circuit. Okay. Hey, so our schematic diagram, we have a battery. You come up here. Don't worry too much about these current monitors right now. I'll just trace out our light bulbs and our batteries, our wires. You'll see what these values are when we complete our table. Okay, so I come over here and I have a light bulb. Back down and around. I've got, I'll put that light bulb symbol there. I've got another parallel path, a light bulb, and back around. And then finally we have a third parallel path, light bulb, and back around to the battery. Remember, in a parallel circuit, all of the branches, and each of these is a branch, has the same voltage. All right, so I've got a schematic diagram. Let's take a look at this. Hey, I know that this is going to be R1, R2, and R3, the resistance of our light bulbs. In a parallel circuit, remember, each of our branches has the same voltage. So with that, I know that this is 15 volts. This is 15 volts. And this is 15 volts. If that branch had more than one element, we'd have to use some of our rules of a series circuit. But from the beginning to the end of the branch, the voltages are all the same. Hey, let's go take a look at this. And I know that I'm going to look at my current here for each of the items. Remember, Ohm's law applies for the circuit in general and for each element in it. So the current passing through R1 is going to be our voltage on R1 divided by the resistance of R1. Our voltage, 15 volts. Our resistance, 20 ohms. 15 divided by 20 is 0.75 amps. So our current 0.75, make that a little bit darker. Hey, just to help out things, here amps. These are in ohms, voltage is in volts, and our power is in watts. Okay, let's do the same for our current through R2 is 15 volts divided by 3 ohms. 15 divided by 3 is 5 amps. So we know this value is 5 amps, and our last value through current, resistance through current 3, 15 volts divided by 15 ohms equals 1 amp. So I have 1 amp here. Hey, in a parallel circuit, the battery supplies voltage for all of these. And Kirchhoff's law, remember, whatever arrives at one point has to leave that point. So I have 1 plus 5 plus 0.65 I have, or sorry, 0.75. I add this up, I get 6.75 amps for the entire circuit. Hey, we can figure out our resistance. Again, remember, Ohm's law applies for the circuit in its entirety and for each of the individual elements. Hey, resistance is equal to voltage divided by current total. Those are T's. My voltage, 15 volts. The current, 6.75 amps. 15 divided by 6.75, put that in the calculator. I find out it's just a little bit over 2. About 2.2, keeps on going on after that. Ohms. So I'll stop at that point. 2.2 ohms. And it fits where this value, our resistance of our parallel circuit, is less than any single branch along our parallel circuit arrangement. Our lowest here is 3, so we'd expect that this would be no more than 3. In fact, it's a little bit less than that. All right. Hey, so my power, I multiply my volts times my currents, 15 volts times 1 amp. I have 15 watts here. 5 amps times 15 volts, I have 15 times 5, I have 75 watts. This last one, 0.75 times 15, like it's a little bit trickier. What is that? That's like 12.5. Give me a moment to figure this one out. Hey, so a little quick check in the calculator. 15 times 0.075 is equal to 11.25. Power in our full circuit, we can add up each of those to find out. So I have, what is that, 15 and 75, that's 80, 90, 91.25. 91.25 watts. All right, if we did, let's see, 15 times 6.75, we'll be very close to that. We'll be slightly, yep, actually, I guess we get that exactly. Hey, so let's take a look at this. How much current is leaving the battery? We find, I'll put it, 6.75. Sorry about the small writing here, just to fit it in here. 6.75. Down, let's see, R1, I know I have, I'm going to change colors on this just so we can see a little bit easier. Let's go pick a good color. Hey, so I picked this light blue. Right, down R1, I know that there's, hopefully this contrast, 0.75 flowing through this light bulb, which means on the other side, 0.75. Means we have 6 amps flowing through here, and out of that we have 5 amps going down R2. If it goes to the light bulb, there must be 5 amps here as well. That 6 amps, that leaves 1 amp over here. 1 amp is flowing into R3, going through the light bulb, and then 1 amp here. Right. Coming back around, we have our 1 plus our 5 plus our 0.75. This is, I'll just write it over here, 6.75 amps returning to the battery. Let's take a look at the voltage here. Right here, we have a 15-volt battery. I think I'm going to pick black for these. That'll help us see these. Hey, this is going to be a little bit boring. I got 0 volts over on this side. I have 15 volts here. 15 volts here. 15 volts here, 15 volts here, 15 volts. I have no drop in voltage across along that current meter, but it all drops to 0 on the other side of each of these light bulbs. 15, 0, 15, 0, 0, 0, 0. All right, let's go ahead and we'll do our voltage graph. Now our voltage graph is going to look a little bit different because we're going to have multiple paths or parallel paths dropping down from that high voltage. I start at 0 at position 1. I'm up at 15. So let's go ahead and we'll draw that in. All right, I'm going to trace the circuit around on the outside. So I have 15 at position 1, 2, 3, 4, 5, 6. So all the way up to position 6, I'm at 15 volts. Going around the outside at position 7, it's at 0. And then it remains at 0 all the way around, past 11, back down to 0. Let's take a look where these other ones start dropping off. All right, so R2, we get to 4, and 1 position past 4, that drops off. So I'm at 4, 1 position past that, and that drops off. Oops, I'm not drawing this very well. Pause for a moment. Okay, let's try to pick that up again. So I'm going to look at R1. I have 1, 2, 3, one pass there. It goes from 15 to 0, so I'll go from 3, 4, and then as best I can, I'll try dropping this down here. Okay, we're at position 4, one more to 5, and it drops down to 0. 5, and it comes down an angle to 6. All right, and all these are now at 0 volts. So we're at 0 volts here. So what do we see? We start off at 0. We're raised to 15 volts by the battery. As we go along here, we can find there's a path that drops down, another parallel path that drops down, another parallel path that drops down. And just like in the parallel circuit, there are multiple paths. We can see that in the graph. There are multiple paths, but each of them have a voltage drop of 15 volts across each of these branches. And for now, that's physics.